Good morning. Good morning. It's Mitchell Prentice here, and today we're looking at substitution into algebraic expressions. Okay, this is a really important skill to know because there's a number of topics that come up where we have to substitute into, say, a function and therefore work out what the output of a function is. It also is used for every single formula that we are given, and through the years we'll do a number of formula sheets, or do a number of formulas that are on the formula sheet, and we need to know how to substitute given values and replace the letters with that given value. So let's have a look at some examples of this and what I mean by what I was just saying. So, for example, you guys have already seen the some things like this. So just say I got an algebraic expression, and the algebraic expression is 2x minus 3. Okay? From last session, you should know what this is. It's an expression with two terms. Okay? The first term is 2x. Okay, the pronumeral is x, the coefficient of x is 2, and it's got a constant term of -3. So hopefully that all makes sense with what I just said. But what we want to do is find the values for different values of x. Okay, so for example, for this, if I just said when x is equal to 0, what does this expression become? Okay, and for this we can see it becomes what? 2 times 0 minus 3. Now if you can't do that, you could just always use your calculator. 2 times brackets 0 and then minus 3. So you can see that what it's going to become straight away is there. However, what we need to do is we need to make sure we practice actually showing what we put in our calculator. So I replace the x with 0, so it becomes 2 times 0 minus 3. Okay, so that's what it becomes, which is -3. Okay, when x just say x is 5, then we can see what this expression is. It becomes 2 times 5 minus 3. Okay, and I will just change this on my calculator to 5. I just change the 0 to 5, press equals, so it becomes 7. Okay, it becomes 7. And now what we will do is I'm just saying I've just substituted two different values for x into this expression. And what we want to do is we want to be able to substitute lots of values into an expression. So we often use a table to do that. So e.g. 2, just say I have another expression, just say I had 5 minus 2x. Okay, so I've got the expression 5 minus 2x, and I actually want to do a table to show different values of for different things of x. So let's have a look and see. So this is what my table will look like. Okay, and I can see I'm going to have a few things. I'm going to say for different values of x, just say I want values of 0 or 1 or 2 or 3 or 4. So I'm going to actually find 5 different values of x, and I want to know what is this expression equal to. What is 5 minus 2x? What is that equal to? Okay, and that's where I'm just going to use my calculator I'm going to say when x is 0, or this expression is 0, I can straight away say it's 5 minus 2 times nothing is 5. But I actually want to put my value in the calculator and see 5 minus 2 times... Now, in your calculator, if I just go times 0 like that, it actually does it for me. I didn't even need to write times there. But now I can do the same thing for 1. I can go 5 minus 2 times 1, which is 3. Okay, because 5 minus 2 is 3. The next one is 5 minus 2 times 2, which is 5 minus 4. Okay, 5 minus 2 times 2 is 1. 5 minus 2 times 3. 5 minus 6 is negative 1. And 5 minus 4, which is... 5 minus 2 times 4, 5 minus 8, which is negative 3. Okay, so this is a table, and it shows for different values of x, what is the expression 5 minus 2x, what value does it hold? Okay, I should actually have a line there just to make it look a lot nicer. Now, EG3 though. EG3, and I'll put a different color. What about when I'm substituting in a negative value? Okay, I'm going to start with this, and then I'm going to do a harder one and then see with some squares. So I'm just going to use the same thing there. I'm going to say, here's my table. Okay, exact same thing, but what about my x values? What about if I had negative 3? What about if I had negative 2? Or what about if I had negative 1? Okay, now let's have a look and see what they become. 5 minus 2x. If I replace this with negative 3, it will tell me it straight away. Okay, 11. But I just want you to remember how it got 11. Okay, 5 minus 2 times x, and x is negative 3. So this is 5 minus 2 times negative 3. And what we get just there, you got just there, 5 minus 2 times minus 3 is a negative times a negative, actually made it plus 6. Okay, and that's why we've got 5 plus 6, which is 11. So please just remember, when you're going through and you're substituting negative values, it's very common to have a double negative here, or you're taking away a negative number. And this makes it plus. So this one here, 5 minus 2 times minus 2 is the same as 5 plus 4, which is 9. And the next one is just going to be 7. I won't do that there. But have a look at the pattern if I joined these two. It's going negative 3, negative 1, 1, 3, 5, and then when we went to the next one, it was 7, 9, 11. Okay, it's following a pattern going along. And if we went the other way, it went 11, 9, 7, 5, 3, 1, minus 1, and then minus 3. It's going down by 2. Okay, that pattern we'll recognize in a future topic. I might rub off this EG3 and then write this EG3 in green. Okay, what about if we had a squared number? Okay, so just say we have 2x squared plus 3. 2x squared plus 3. Okay, let's have a look and see what values we actually get. So firstly, when x is equal to 4. So just not getting confused with the other things. Does this mean that it's 2x and then or squared, or does this mean that it's just the x that is squared? Okay, now hopefully when we're remembering our year 7 work, when we're seeing 2x squared, I'm just going to write here, remember 2x squared means 2 times x squared. Okay, 2 times x. Okay, it is not 2 times 4, which is 8, and then 8 squared. Okay, it's 2 times 4 squared. Okay, a lot of students get this wrong and they just go 8 squared, which is 64, but that's not the case. It's 2 times 4 squared, so it's 2 times 16 instead. So what we get, wrong color, when x equals 4, it becomes, and we write down what we're subbing in, 2 times 4 squared plus 3. And I just could use my calculator, 2 times 4 squared, okay, 2 times 16 is 30, whatever it is, 32 plus 3, so 35, okay, so it becomes 35. Okay, what about if you're substituting a negative number in? So when x is equal to negative, say negative 5. When x equals negative 5. Okay, and what we get there is it becomes 2 times negative 5 squared plus 3. Okay, so 2 times negative 5, doesn't matter which one we use. Okay, and this is why we always substitute in and use brackets with what we're substituting in, because negative 5 squared is the same as negative 5 times negative 5, which is actually a positive answer, which is positive 25. Okay, so we get 2 times positive 25, which is 50, plus 3. Okay, so we get 53. So when we have a squared, even the negative number is going to square to become positive. Okay, now let's have a go with putting this in some formulas. So e.g., okay, substituting into formulas. Okay, please have the heading, substituting into formulas. Okay, I'll just write formulas. Notice some people use an E for formulae or formulae, and then other people write an S. Okay, so when we've got plural, it doesn't really matter what you use. Okay, so e.g., just say we've got a formula like basic shape. So let's say the area is equal to pi r squared. Okay, so we should always write down when r is equal to, say, 7.3 centimeters. Doesn't really matter. Okay, if you ever get a question like this, there should be 3 lines of working. Okay, at least 3 lines of working, I should say. Your 3 lines of working should always be, what is the formula? So you write down a equals pi r squared. Okay, the next line, to substitute into the formula, so replacing with what you've given in the formula, so area is pi times 7.3 squared, and then you calculate. Okay, we never use just the answer. You should always have at least 3 lines of working. So we go pi times brackets 7.3 squared. So it's 167.42. Because I gave centimeters, I know it's an area, so it's square centimeters, and that was to 2 decimal places. Okay, because it kept going. I know it's always going to have decimal places because it had pi in it, which is irrational. Okay, let's have a look at another example, EG2. So just say I want to look at the volume of a cube. We see 4/3 of pi r cubed is the formula. That's the formula for the volume of a cube, sorry, a sphere. 4/3 of pi r cubed is the volume of a sphere when r is equal to, say, 6.2 meters. That is absolutely massive, that sphere. Remember, the diameter is 12.4. So that is a sphere. This sphere is, way bigger than our classrooms and whatnot. It's going to be massive. Okay, but what we get, just showing you've got 3 things we do. Volume is 4/3 of pi r cubed. Okay, write the formula down. I'm going to zoom in. Okay, then write what you're showing to substitute in. So the volume is equal to 4/3 times pi times 6.2 cubed. Okay, and then actually do the calculations. You have to show the working. So 4/3 times pi times 6.2 cubed. Okay, there's the cubed button. So 998.31, and that is 998.31, and that's cubic meters because it was a volume. Okay, that is absolutely massive, like I said, to 2 decimal places. Okay, I'm going to leave you with one more substitution, and that is, let's have a look and see, that's going to be EG3, the surface area of a cylinder, and that's found by using the formula 2 pi r squared for the 2 circles, the top and the bottom circle of a cylinder, the 2 circles on the top and bottom, plus 2 pi r h. That's the curved part that wraps around a cylinder. Okay, so if I drew it, the 2 pi r squareds are that one there and that one there, and then the 2 pi r h part is the part that wraps around it, so all of that all the way around. Okay, so that's that there. And let's say, what is the surface area all the way around that cylinder when r is, say, 4 centimeters and h, the height of the cylinder, is, say, maybe 12 centimeters. We'll just have whole numbers, that's fine. Okay, so what is the surface of this whole cylinder given that the radius from the center to the outside is 4 and the height of that cylinder, like that red line just there, is 12. Okay, and at least 3 lines of working, and we say, where's a good color? Blue. Surface area, so rewrite the formula. 2 pi r squared plus 2 pi r h. Okay, we have to always write the formula. Most of the time you don't even get given a formula, but I'm just giving you them because you guys are, normally go and have to go find them. But I'm giving it to you in this question, and then we show what we're substituting in. So r is 4, 2 times pi times 4 squared, plus 2 times pi times 4 times 12. Okay, see how what I substitute in? I write them in brackets. So I've replaced the r with 4, I've replaced that r with 4, and I've replaced that h with 12. Okay, and then I can just use my calculator, and and I can literally type that in. 2 times pi times 4 squared, okay, plus 2 times pi times 4 times 12. Okay, so that's the answer. It's 402.12 square centimeters to 2 decimal places. Okay, I hope that is helpful. Good luck with your work.